Now, in today's episode of our lesson, we are going to be talking on the kinetic theory of matter. Okay, the kinetic theory of matter, and we are going to start by defining different terms that will help us understand what kinetic theory of matter is. Now, already we know. Let's start by defining matter. Already we know from our from lessons and then in junior levels we have defined matter as anything that have weight and occupied space. Normally, I know you know that. Now, okay, so but now I want to define matter again as anything that have mass and occupy space. Okay, anything that have mass and occupy space, that is what we call matter. Now, matter is made up of very tiny particles, such as atoms, molecules, and ions. Okay, atoms is made up of atoms, molecules, ions. So now that is what matter is made up of. Now, the kinetic theory of matter postulates that these particles are in constant motion and possess kinetic energy. I take that again. The kinetic theory of matter postulates that these particles, that the particles that made up matter, are in constant motion and possess kinetic energy. Okay? Now, an increase in temperature of any system increases the average kinetic energy of the system. The increase in temperature of any system increases the average kinetic energy of the system. For example, if you bring water, put it inside a pot and put it on fire or boil it, once the temperature starts increasing, you notice that the kinetic energy, the energy of the water will start to increase. And if you put your hand inside the water, you will feel the energy in form of heat. Okay, and if you continue to heat it at some point, the energy will become so much that the water will start to evaporate. Okay, so any change in temperature leads to a corresponding change in the kinetic energy of the system. All right, so now we say average kinetic energy because in any given system or in any given sample, the whole particles in that system don't have the same energy. Some particles have higher energy while some particles have lower energy, and some particles their energy is just the minimum, or is just in between the ones that have high energy and the ones that have lower energy. So that's why we use the word average kinetic energy, because we're taking average of the whole energy of the different particles that makes up the system. Okay, that's why you usually say the average kinetic energy of matter of the system. All right, so now let's look at states of matter. Now, matter have different states. Matter exists in different states. Majorly, matter exists in three different states. Okay, number one state of matter is solid. Then the second state is liquid, and the third state is gaseous. So we have solid matter, we have liquid matter, and we have gaseous matter. Okay, so we're going to be taking these states of matter one by one and be discussing them and their characteristics. Okay, alright, so now let's take a look at solid states. So a solid has definite volume and it also has a definite shape. For example, pick up a stone. A stone is an example of a solid. You see that it has a definite shape, it has shape and it has volume. You that is looking at me, you have a shape. Remember that you have a shape. So and you have a definite volume. Okay? So you are an example of a solid. Alright, that's by the way. Okay, so now a liquid don't have a definite shape. Okay? A liquid don't have a definite shape, but it has a definite volume. Alright? A liquid takes the shape of the container, but it has a definite volume. Now, a gas has no definite shape and has no definite volume. So let's now these states of matter can be changed from one matter can be interchanged. What do I mean by that? I mean that a matter can change state from one state to the other, like from solid to liquid and to gas, and also it can change from gas to liquid to solid. But the most common example is water. We all know that we have the solid form of water, we have the liquid form of water, and we have the gaseous form of water. For example, if you bring water, put it inside a container and put it inside a refrigerator, or the environment is so cold that the temperature drops up to -1 degree Celsius, or it is up to 0 degrees Celsius, from 0 to -1, 2, and so on degrees Celsius. Discover that the water will become very cold and it will block. And once it blocks, it forms the solid form of water, and that is what we call ice. Okay? Now, that ice, if you heat ice and the temperature rises to 1 degree centigrade or is higher than 0 degrees centigrade or Celsius, you will discover that it will turn back to liquid. And as you continue to heat it along the line, it gets to 100 degrees centigrade. You will now see that it will start changing from liquid to gaseous, because it will start evaporating. It will turn to vapor from which is the gaseous form, and it will be evaporating. Okay, so you see, it can change from one form to another. So there are some materials that actually can change from solid directly to gaseous states. Materials like something like iodine. If you drop it and leave it exposed, it will change directly from solid to gaseous state. And such materials is one they say the materials sublime. Okay, that's an example of sublimation. The material just sublime and change directly to that. So you see that the states of matter are interchangeable. Okay, well, a matter can undergo different states, which are the solid, the liquid, and the gaseous. Now, let's look at the solid state of matter. Now, I've already told you that the solids have definite shape and definite volume. Okay, it has definite shape and definite volume. So let's look at other characteristics of solid. Please pay close attention, because this topic it might look so simple, but it's a very important topic in science. And in exams, they ask this question a lot. Even in JAM, they ask this question a lot. Okay, so just pay close attention as we journey. Now, take note of the postulates. Take note of the characteristics of these different states of matter. Okay, now in solid, the particle or the atom are closely packed together. Okay, and the force that binds the molecule of the solid together is very strong. The solids have very strong force that binds the particles and the molecules together. Okay, now the molecules in this particle, they don't have a large degree of freedom. Okay, they are very together and it's very strong. The molecule in this particle have no freedom of movement. That's what I mean by degree of freedom. Degree of freedom simply means freedom of movement. So they cannot move anyhow. You are just looking at them, they are just there. They cannot move and they don't have the freedom of movement. That's what I mean, that they don't have the different degree of freedom. Okay, so now, but that doesn't mean the particles are not, they are moving about a mean position. Okay, that means it is vibrating. Even I use this as an example of a solid. If you check very well, you find out that your body is vibrating, but your shape remains your shape. Okay, so you are a solid, you are the same, you are not moving, you are packed together, but it's vibrating about a mean position. So your particles that make up your body cannot just leave like that. But that does not mean it's vibrating or in constant motion, but it doesn't have the freedom to move about as it likes. Okay, that is solid for you. So how many points have you made now? You have made 3 points. It has a definite volume, number 1. Number 2, you have a definite shape. Number 3 is that it is bound together by strong force. So it doesn't have what? Degree of freedom. It doesn't have freedom of movement, so it cannot move anyhow. Solid don't have freedom of what? When you apply heat to it, so you supply energy to it. it will melt, and when it melts, it turns to another state, which is what? The liquid state. So now let's take a look at the characteristics of the liquid. Alright, so the liquid in the liquid state, okay, in the liquid state, particles together is not as strong as the forces binding the solid particles together. So the liquid particles of matter has a little degree of freedom. That's it have a little freedom of movement. It can move, but it cannot move so much like the gaseous molecules. But liquid molecules or liquid particles, they can move about a short distance from each other. Okay, so now in the liquid state, e have a definite volume, but it doesn't have a definite shape. It takes the shape of the container. Now, when you apply energy, or when you supply energy to a system or a liquid system, okay, the energy will increase, and when it reach the temperature, when the pressure in that liquid phase reaches the atmospheric pressure, okay, when it reaches the atmospheric pressure, then it will start boiling, and that is what we call the vapor pressure. When it's equal to the atmospheric pressure, it will start boiling, and it can change form from the liquid phase to the gaseous phase. So let's take a look at the properties of liquid again. Number one is that the forces binding them is not as strong as the forces binding the solid form. Now, number two is that they have a little freedom of movement, or a little degree of freedom, which means the liquids can move, but it cannot move so freely like the gaseous state, but it can move a little. Then the third one is that it has definite volume but no definite shape. Okay. Now, when you supply energy, or when you supply heat to the liquid at a certain temperature, it will turn to gases. So now let's take a look at the property of gases. Let's take a look at the properties of gases. Now, in gases, gases have much more degree of freedom. It has much more degree of that. They have a very large freedom of movement. So gases can move anyhow. In fact, gases don't have any definite volume, and they don't have any definite shape. For example, your cooking gas at home, the gas you use at home to cook, if you like, put very small quantity of the gas inside a 12.5 kg container, the gas will still come. It will fill the container. If you still compress it, let's say it was 1 kg gas, if you still compress it to 3 kg container, it will still be there, and it will fill the container. So gases fill, in fact, a whole room, as big as a room is, if you put in a small gas inside the room, the gas will fill up the spaces inside that room. So it have no definite shape and no definite volume. It takes the volume and the shape of the container. Okay, so now gases move with a large speed, like with a very which word do I use to call? With a very fast speed, it moves with a very fast speed, and the molecules keep on moving randomly and sometimes colliding with one another at some intervals. Okay, so that is it for gases. Gases have no definite shape, no definite volume, has high degree of freedom, or high freedom of movement. So that is it for properties of gases. Now, I've already said that you can actually move from gaseous phase back to liquid phase and back to solid phase. Now, let's look at melting. What is melting? Now, when a solid is heated, the particles acquire much energy. Okay, when a solid is heated, the particles acquire more energy, and as you continue to supply to heat it, the energy continue. At a point, the energy will become so much that the forces holding the particles together can no longer hold it together again, because it is also acquiring much energy, and as the acquiring energy is, let me just use the word that is fighting with the forces that is holding the particles together. And at some point, the energy will become so much that it becomes more than the energy binding the particles of the solid together. And at that point, the binding forces can no longer hold the particles of the solid together. And then what will happen? What will happen is that the solid will melt, and it will melt and change from solid state to the liquid state. So that is what melting is. So that point at which the energy of the particle when it is heated is equal to the energy the forces holding the solid particle together. That point at which it now changes from solid to liquid is the point we call the melting point. That's the melting point of such particles. Okay, so that's the melting point of that particle. Now, the particles are no longer held together. That's when it now changes, it now melts. The particles will no longer be held together by that forces of cohesion that is holding the solid particles together. So now let's look at evaporation. What is evaporation? Now, evaporation involves heat. Okay, evaporation involves heat. When you supply heat to a system, at some point the particles of the system will start to evaporate, like start going away, going off. That's when then you say evaporation is taking place. So evaporation involves the heating of a liquid, or example like water, so that the liquid changes from the liquid state to the gaseous state. Evaporation is the heating of a liquid so that the liquid changes from its liquid state to a gaseous state. That is what we call evaporation. Now, what are difference between evaporation and boiling? Because this is a very important point. Difference between evaporation and boiling. In almost every exam they ask this question, so just take notes. Now, number one is that in evaporation, the energy is supplied to the evaporating particle by the liquid particle. The energy is supplied to the evaporating particle by the liquid particle. Now, evaporation doesn't necessarily mean that it must be when you consciously apply heat that the evaporation will take place. No. If you apply heat, good and fine, the evaporation will be faster to take place. But even if you drop like your fuel now, if you bring fuel, open it and drop it in open container, it will keep on evaporating. And if you come, like let's say you keep it today, if you come back tomorrow, the quantity of it, what happened? It's evaporated. Okay, it's evaporated. Now, but the energy needed for boiling is usually supplied by an external source. For example, if you want to boil water, you have to supply the heat from an external source, like maybe from the Bunsen burner or from your stove, or from electric cooker or electric boiler. You use it to supply external heat, and then the system will boil. Okay. Now, number two, that's the second difference between evaporation and boiling. Is that evaporation takes place at any temperature. It doesn't have a definite temperature. It takes place at any temperature. But boiling doesn't take place at any temperature. Boiling have a definite temperature at which it takes place. For example, water boils at 100 degrees centigrade. So once you heat water, when the temperature is up to 100 degrees centigrade, water will boil. Okay? But for evaporation can take place at any temperature. Okay? So now, the third point, or the third difference between evaporation and boiling, is that for evaporation, the pressure don't need to be equal to the vapor pressure don't need to be equal to the atmospheric pressure, so it can take place in any pressure at all. But for boiling, the vapor pressure must be equal to the atmospheric pressure before boiling can take place. In fact, if you are boiling and boiling supply heat, heating it, and the vapor pressure of that water is not equal to the atmospheric pressure in the place you are heating the, let's say use water for example. If the place you are heating the water cannot boil until the vapor pressure is equal to the atmospheric pressure. So in evaporation, it takes place at any pressure. The vapor pressure don't need to be equal to the atmospheric pressure, but for boiling, the atmospheric pressure must be equal to the vapor pressure before boiling can take place. So let me take a recap again at the difference. Number one difference is that energy for evaporation is supplied by absorbing energy from other particles surrounding the particle that want to evaporate. But for boiling, it's the energy supplied from an external source like the stove, electric cooker, or electric boiler, or from a Bunsen burner. But now, the second one is that for evaporation takes place at any temperature, or boiling takes place at definite temperature. Now, the third one is that evaporation takes place at any pressure. It doesn't require the atmospheric pressure to be equal to the vapor pressure, but in boiling, the atmospheric pressure must be equal to the vapor pressure. So this is where we are going to end the lesson for today on the kinetic theory of matter. So see you in our next class. So make sure you subscribe to our channel, share this video to your friends, and ask your friends to come and subscribe too. So to subscribe, like and comment. If you have any questions, you can drop it on the comment section so we can look at it and then answer your questions. And if you have any contribution, you can also make that in the comment section. Thank you so much for watching this video. See you in our next video.